Good morning, my dear students. Uh, Now we are discussing, this is the first class of your applied hydraulics subject. Okay, we have a subject called as applied hydraulics. The syllabus is framed by VTU University that we are going to consider, and the subject code as per VTU is 18CV 43. Okay, and this is our module 1. In this module 1, the syllabus included here is, we can say there are 3 chapters in this module 1. The first one is a dimensional analysis, and the second chapter is a model analysis, and the third chapter we can say that is a buoyancy and flotation. Okay, and in the first chapter we have, that is the dimensional analysis is the first chapter. In that analysis and similitude it is there, and dimensional homogeneity we need to study, and non-dimensional parameters, and Rayleigh's method and Buckingham's pi method. Okay, this is a pi method. These two methods are very important, and which covers the major portion of this chapter, that is Rayleigh's method and Buckingham's pi method. Then dimensional analysis, choice of variables, examples on various applications. This much we are going to cover in this first chapter of this module 1. Okay, let us start with the module 1. Now what do you mean by, first we will go by words. What is the meaning of dimensions? For example, velocity is there. How to measure a particular vehicle's velocity? Then I should know how many meters it covers in a particular second. Then how to measure the that amount of fruits? Okay, this is one that one basket, and there are fruits are there. How to measure how many fruits are there? Then I will measure in terms of kg, that is your mass. That I will measure in terms of mass. How to measure that time? How to measure the time? Then I will measure with respect to seconds. How many seconds are hours, like that. Now these are all dimensions, which you already know the meaning of dimensions, because this is already studied by you in your pre-university courses. Okay. Now what do you mean by similitude? Similitude means comparing two quantities, or two parameters, comparing two parameters, or I can say not only comparing, equating two parameters or two quantities. For example, I am equating this force to the product of mass and acceleration. See, I am comparing force with the mass and acceleration, the product of mass and acceleration. Think that before Newton, you don't know whether this equation exists or not. But individually you know that force means what? Force means some instrument is that what you push, how you push, and this pushing you call it as a force. This you know, independently you know. Then what is this mass? That you know. Mass means something which will be occupying some area, some volume or some area. That is your mass. You know the meaning of mass. What is acceleration? Acceleration, you know, the rate of change of velocity is the acceleration. This you know, but individually you know this. Okay, you know this. But Newton came and he established the equation F equal to ma. Then this is called as similitude. Here he said that to know how much force is acting, he require mass and acceleration of both. Then product of them will give you the force. Then what is the unit of force? We will call it as a Newton. Then what is the unit of mass? It's a kg. What is the unit of acceleration? That is your meter per second square. Then the similitude tells that 1 Newton means 1 kg meter per second square. Got it? Means it is just a comparing this one. Okay, this whatever the I compared here, I can say that this is a mathematical comparison. comparison. Then otherwise sometimes we can make it models and prototypes. Okay, for example, I have one car. Okay, this car is there, and I would like to know when this is moving with 100 kmph, how much how it will resist the wind coming to the front. I want to study. Then I cannot make one original car and run with the 100 kmph and measure that one. That is somewhat very impossible thing. That's why what I do, I will make a model car. Okay, na? I will make a small model car, and that model car I will run in my laboratory, and with some arrangement, some fan I will put here, and from the fan some that wind will come, and these all things I will do it. Okay, how exactly I do, this chapter will teach you. Okay, how to reduce these dimensions, na? How much we need to reduce these dimensions, or is there any scale to reduce that one, and how to reduce this speed of the vehicle, how to reduce this amount of wind which is coming front, na? That how to make this exactly equal prototype or exactly equal model, that we are going to study in this chapter. Okay, next class we will study exactly what are the dimensions, what are the fundamental dimensions, and what are the derived dimensions, and we'll begin with the chapter. Thank you.